Alright, so this is my lab report on Lab 7, resistors in series and parallel. The main goal of this lab was to calculate the equivalent resistance for a couple of different circuits. We pulled this off in two main different ways. The first way was by measuring the current going through the battery used in each circuit, and by measuring the total voltage across the different combinations of resistors in each circuit. The second way that we found the equivalent resistance was using Kirchhoff's rules. The loop rule and the junction rule were used to confirm the values of current and voltage in each of the prior circuits. So to start for this, in the pre-lab, we used a digital multimeter as an ohm meter to measure the resistance of three different resistors that we had. Then using that, we did calculations to find the equivalent resistance of three different scenarios or circuits that we were going to use in lab. And then using Ohm's law, we calculated the current going through each of those circuits, assuming a voltage of 1.5 volts from the battery. Moving on to the lab, we set up each of the circuits that we did calculations for in the pre-lab, and we took measurements for the current flowing through the battery in each circuit and measured the total voltage difference across the different configurations of resistors, and used those measured values to calculate the equivalent resistance using Ohm's law. So we basically just did the reverse of what we did in the pre-lab. The pre-lab, we used the equivalent resistance to calculate current. This time we used current and whatnot to calculate Ohm's law. To finish things up, we then used Kirchhoff's loop rule and junction rule to find the current and voltages in some of the circuits. We didn't do all of them though. So here you see two tables. The one on the left is the table showing the measured resistances of the three resistors that we used for this lab. The table on the right shows the equivalent resistance of the three circuits that we calculated using the resistances, and also the calculated currents that we used the equivalent resistance and a assumed voltage of 1.5 to calculate. Here we have the table showing basically the reverse of the last table. The last table is from the pre-lab. This one's from the beginning of the lab, where we measured the currents going through the batteries in each of the circuits, and the voltages going through the circuits as well. And on the far right of the table, you see the equivalent resistance that we calculated using those two measured values in Ohm's law. Here is where we started using Kirchhoff's rules. On the left, you see a table outlining the two different resistors used in circuit 1. The 0.45 is the voltage going through resistor A, and 0.95 is the voltage going through resistor B. And on the upper right hand corner there, you see the 1.4, that's volts coming from the battery, minus the 0.45 volts of resistor A and 0.95 volts coming from resistor B. Those subtract all of that ends up giving you 0, which is what the loop rule says it should be. Here we use the junction rule on circuit 2, where we found the amps going through resistors B and C. Then you have the amps just going through B and the amps just going through C. and using the junction rule, we did the in equals the out, where the in would be the amps for C and B, and the out would be the amps for B and C combined. So you have 0.026 plus 0.013 equals 0.039, which is roughly what we measured for the amps going through B and C. And finally, here in circuit 3, we used both the loop and the junction rule. On the left there was the stuff we did for the loop rule, where it's the voltages going through the left loop there in circuit 3 and the right loop in circuit 3, and put those together with the 1.44 volts from the battery, and it gives us 0 roughly. And then on the right there you have the table for the junction rule, where it shows the amps measured from resistor A, resistor B, and resistor C, with the amps going through resistor A having to equal the amps going through resistor B and C, in which case it does once you do the math. So that's about it.